We are the team working with Pedigree Technologies. I'm Mark.
I'm Alan.
Megan.
And I'm Riley.
So our sponsor slash mentor, we have Josh DeCock, Wolf Schusted, and Joe Johnson. I'm just going to go through this kind of quickly because we have much less time. But Pedigree Technologies.
Don't try to finish it.
Okay.
We can shift a little.
All right, that's fine. They're a mobile resource management company. They work with a lot of industries, including in our particular case, transportation, but also construction, oil and gas. They have a one-view platform that allows you to manage and communicate with your vehicles and equipment and workers in real time on the screen. Good. Yeah. The problem that we were tasked with addressing is that if their electronic logging system went down, they would have to revert back to paper logs, and they wanted a better solution for scanning those in after the system went back up. So we needed to create a functionality that could scan a graph and extract the data from it, and we developed an Android app for that purpose.
So like Mark just said, the solution to this project was to create an application that will capture an image of the driver's paper log and then scale down to the graph and then convert that data into tabular data. It's mostly intended as an insurance against the system failure. It won't be used, hopefully not too often. For some details of our solution, there's quite a few main portions of our project. The first main portion is to deskew the image and then scale the image, binarize it by removing the red and applying a threshold, segmenting the graph, extracting the data from the graph, and then displaying that data. So for our schedule, Sprint 1 mostly consisted of research on how we are actually going to complete this project. In Sprint 2, we finished the binarization and then began to work on the data extraction and the deskewing, and then finished the basic UI for the app. After the midterm presentation, we were told that a better approach for the binarization is to remove all the red. So we implemented that in Sprint 3, as well as finishing the segmentation, the deskewing, and the app functionality. And then finally in this last sprint, we finished the data extraction and then integrated each of the separate components into one, started testing, and then got the data to display.
All right, so this is just a little view of what our UI looks like. Basically, you're allowed to take a picture with your phone or select an image, and then you would then it gives you it displays the image once you've selected it. You click convert, and then it shows the image to be converted. Once you hit convert graph, it'll show you what it looks like after it's binarized, and then a log of the data.
All right, so for the deskewing portion of the project, first you'll input your image and then the algorithm applies edge detection. So it goes through and calculates differences in color gradient between adjacent pixels, and then if it's within a certain value range, it'll add it to a list of edges. And then after that you will apply contouring, which will take a continuous set of edges and basically create a region that bounds an object, and so that's how it's detecting the rectangle that it's going to determine that is the picture, the piece of paper of the graph. And so currently there's a couple assumptions that it makes. First of all, that there's an exterior bounding around the box of a very dark background. We tried it with a couple different colored backgrounds, and the lighter ones, it just couldn't pick up the edges. So it's got to be done on a dark background, but as long as that's met, it can reliably detect the image. And also, it assumes that the image that we're looking for is the largest 4-point box that encapsulates. So that thing with the highest area that has 4 points that bounds it we are going to consider that the image, and that's worked pretty reliably.
So for our scaling, it's dynamic. So we get the XY coordinate of the top left corner of the graph, and then the distance, the width and the height, and then use the ratio of that width and height in relation to the total width of the entire paper log to make it dynamic and scale the image down. So for the binarization, basically just get the pixel color, and then if it's red, remove it based on the applied threshold, which we used 125. So you can see the red, and then this is kind of a smushed picture of it, but it removes all the red and leaves just the black and white image.
For the data extraction, once I have when all the process has been done and it's been scaled and binarized and the red removal happens, essentially I just see where it's, yeah, this is just the picture I see, and then I start reading from the top left corner, and then I just iterate through each Y location to see and check the threshold. And if it's above a certain value, then there's something there that needs to be recorded. And if it's white, then we just skip that. And once I go through all the graph, I try and get big values to eliminate noise. Even with the red removal, we still have some small dots that just happen to be there. But yeah, I extensively tried to find what the 50-minute interval is, and this varies when I was testing it on the graph that's taken, and hopefully with our dynamic scaling, it's always going to be the same. And then essentially, you just take the 24 hours and divide each segment, and then you divide each segment into 4 smaller parts for 15 minutes. And this is a couple graphs I use for testing. And lastly, I tried, so when you get the allocation for the width, it's just, so if, let's say this width had a 4,000 pixel value for the whole entirety, I just had to translate the, let's say, location 1,000 and try to figure out in what time of the day that was, and just converting that. Also, I segmented the graph, so you start from the top and then you go to the first line for, I believe that was off duty, and then just split the 4 portions into its own segment, iterate through and combined all the data into one big array, and in case just to make sure that no data was lost. And then through that one array, I went through and came up with an algorithm to try and detect if it's a change. So if you see in the top part, it has 4 different timestamps that he was in that segment. So just trying to detect when there's a change in values and record that change. And then when we print it off, it just goes into each segment and adds that to an array with all the values. Now we can move on to our demo. As we mentioned, this is our app. We can't take a picture because an emulator has some preload images that it's going to select. We can go the one with a picture from there, and then we just hit convert. Then we convert the graph. We can also, because even though these lines were straight, I can select a different image that we kind of drew freehandly without a ruler. And I don't know if you, yeah, and even though the lines are not straight. It just detects, the starting location and then when it ends. And if you can see, let's see. Yeah, if you can see like this segment here, even though it's not a straight line everywhere, but as long as it's in that segment, I'm able to record the values, and that's why I add them to one array. So as long as it's in a segment, it's going to be recorded, so there's no data loss. Okay, I think we're done with the demo.
All right, so a few of the risks and issues that we faced along the way. First and foremost, finding open source stuff for what we were trying to do. Because this is a fairly unique problem, there wasn't a lot out there that was custom built for what we wanted to do, so a fair amount of the stuff we actually ended up doing from scratch. We did use a library for the de-skewing, but most everything else we kind of baked up ourselves. And the particular algorithm that I was using for de-skewing, it was a new library, I wasn't very used to it, so there was a lot of working through the data types, and it's not very well documented in Android. It's primarily used with Python and C++, so the documentation is there, but there's just nothing for Java, so I kind of had to infer and translate a lot. And the algorithm for extracting data from the graph wasn't very straightforward. We went through a lot of different iterations on it, and we tried scanning horizontally, we tried scanning vertically, and none of them were quite sufficient, but eventually we compromised and kind of used some of both to get our final result with that. Our post-mortem summary, something we thought went well was that we assigned some very separate components to all of our members, and most of those components are relatively independent, so at each step along the way we could create reasonably good inputs so that each of us could work on our different components of the project separately to keep things moving. And something that wasn't so good is our velocity slowed off quite a lot, shortly after the midterm. We just weren't vigilant about keeping progress moving on it, so we lost a lot of momentum there, and maybe we could have implemented some more features and robustness into our project if we hadn't lost that kind of velocity. Another thing we wanted to improve on was communication with our sponsors, both in terms of keeping them in the loop about our progress and utilizing them as mentors and resources and with their experience. And finally, something that we did well was made a good effort at the end of the semester to get everything wrapped up and in ship shape for showing off. So for the next steps in terms of improvements for this project, a possible thing that could be done is doing some OCR on the different fields on the graph. So there's the driver's handwriting location for where they are at certain points in their time changes. So that's something that could be added. We would also have liked to add functionality to edit the graph in real time. So there's a couple instances where our algorithm is off by 15 minutes or so, and that was something our sponsors were comfortable with. But it'd also be nice to have the user say, oh, that's 15 minutes off, I'll move that back 15 minutes. And finally, we add some functions to check if the graph is valid. So if there weren't any vertical lines in the graph, it shouldn't accept it, because if there's no time changes, you can't really read it. And if there was overlapping times in different segments, so they were doing two different things at once, it shouldn't accept it in that case. Any questions?
How do you deal with smudges and things like that on graphs? Like, say someone were to run your hand over the ink ball was still wet.
The threshold for our binarization should just remove that because it's not dark enough to be considered an actual line.
The main line that was drawn will be significantly darker than that smush, and so when it's binarized, it'll filter out that information.
What does the app do with this data when it's finished with it? Does it save it to a file that can be sent to the company or database or something? Or does it just display it?
All it's doing right now is displaying it.
But yeah, it would just have to be into a file. It's just another step. But yeah, it's just been stored in array, and then it just in the folder that displays it.
Is there any way that, is there anything to put in place to keep two of the same time being sent for different, like, actions? Like, if they have marked it in such a way that there was overlap, could there be a 15-minute chunk that they were both sleeping and driving?
Yeah, that's one of the features that we didn't get to. We wanted, like we said on those last steps there, that it doesn't currently check for that. So something we would have implemented had we enough time to do so.
I like this. You were showing you had 4 examples. You picked the first 2, and then there was one that was a really wrinkly one. I was just wondering, how did that work out?
It's
You got
a lot better than you might expect, but it's
So
not.
if you got that, I'd be impressed.
It does.
I don't
It
think
does pick it up, but I
We
mean,
actually have.
there's no data on here though, so
Yeah, we didn't
So we're
try.
using that image to check the
I was just
skewing.
doing that for de-skewing. I mean, you can show off what it might crash if you do this.
it shouldn't crash
It just won't be.
because there's nothing to read. But,
Oh, it does actually display something.
Yeah.
Just not right at all.
actually,
I had that one really messed up to
That's kinda
see
funny.
if it would work. So.
so it's actually picking up the shade.
Yeah, the shadows.
Yeah.
And the shadows are actually how I figured out how to make my algorithm work. Because when I was reading it on light background, the only edges that it was picking up was the ones on the shadows. So that's how I kind of figured out it had to be dark on the background.
Interesting.
I think if you could get it to deal with that, it sounds like there's
Like
probably a
also,
PhD thesis in there somewhere.
also like this one would crash because there's not enough binding.
Yeah.
Right.
Of dark
Like I was saying
around.
earlier, it has to be bounded because otherwise it can't detect an edge between things, so it won't be able to calculate the right graph, and it'll just find the interior graph portion or something in between.
Does it give error messages in that case, or is it just kind of keel over?
Currently, I believe it just keels over. But
Yeah. I don't think
something
anything
I
has to.
intended to have an exception handled for.
Do you have any ideas of how you might identify when one of the inputs is invalid or bad? So like, if it's just something nonsensical, someone scribbles on the paper, or like that one that was blank but crumpled. I'm just curious if like while you're implementing some of these algorithms, if you had some ideas for like, oh, this is clearly out of the range we're expecting, so we can throw this out.
I think it's possible that being able to detect bad graphs would be more difficult than being able to extract data from good ones.
Sure.
I mean, you can always, there's some ways that I've thought of to do it. You can, like Alan was saying, you could go through your 4 arrays of different states, and if there's more than one, if you say you're in this state at 8 o'clock and this state at 8 o'clock, and they're both, if you're off duty and sleeping at the same time, it wouldn't accept that. So you would just kind of iterate through your different arrays containing the states and times. That would filter out quite a few of those kind of errors.
Because reading all the data, first time, like it's all in. I have all the data at all times, and then it's just about figuring out in what segment it is and filtering out that way. So once it is displayed in an array, and I can just check if there are duplicates, and if they are, then I just throw an error.
What happens if you go so far along the line and then you make a vertical line and then the vertical line drifts 15 minutes forward or 15 minutes backwards from where it started at the top?
Yeah, there's no way for me to the way I have it in the algorithm, because the way I'm detecting it at the moment. So let's say this line is location 200, or it's in a segment, and it doesn't really matter where it's in the segment. It just binds everything together, and then I just check for the starting location. So it just checks for that.
It would just be off by 15 minutes in that
Yeah.
case. It would still be able to pick it up. It would just detect it as being 15 minutes later than it rightfully would be.
Okay, thank you.